Okay, and then this is just kind of the notes are on here, so just in case you need them. Um, and that's the worksheets up here, the blank with the answer key. This week, this is kind of what we're using. We're using kind of this middle set, all these middle ones, acid and bases. This is the PowerPoint. These are the notes. These two top worksheets, these are kind of worksheets, just, I gave you two different worksheets. So I gave you these, this is acid base, okay? And then this is the key for that worksheet. And then I gave you another worksheet down here, which is kind of the similar ones that we've been doing. That's that worksheet. And then I gave you the answer key to that as well. What's the rest of this then? So one is the newsletter. This one is the note card. This note card we will discuss more Monday, just an FYI. Okay, and then this week 13 newsletter. This is just kind of what we are going to do this week. We're going to, first of all, the objective is kind of the same. We're going to use subscripts and parentheses to determine the number of atoms represented in a formula. We're going to learn how to write the names of acids and bases, and then how to write the formulas of acids and bases as well. So nobody from this class has element of the week because we only have 2 people and they already did it. And then we have, like I said, the second part of the lecture today, okay, that we're going to continue. Okay, so that's kind of this week. Let me actually share my tablet because that's where we're going to do our lecture today. Come on. Give me 1 second. Let me. That worked. Oh, sorry. It's not even connected. That's why. There we go. Sorry, I wasn't like, why isn't it working? It wasn't even connected to the computer. All right, there we go. So we're writing acid formulas today. So we're going to focus on that. So yesterday we talked about writing the name. So I gave you the formula, you gave me the name. Now I'm going to ask you to, from the name, give me the formula. Okay. So how are we going to, so first of all, remember, like I said before, we have 2 types of acids. Okay, we have acids with oxygen and acids without oxygen. Again, we have acids with oxygen, we have acids without oxygen. So let's talk about first what we call hydroacids. These are acids without oxygen. Again, these are acids without oxygen. So to write these, we write the positive is always H plus 1. Okay. The positive is always going to be H plus 1. So no matter what kind of acid it is, meaning no matter if it's has oxygen or no oxygen, the positive is always going to be H plus 1. Now, how are we going to write them? The nonmetal, then the second part is going to be a nonmetal, meaning just an element from the right-hand side and the charge. Okay, it's going to be a nonmetal from the right-hand side and the charge. All right. And then we're going to balance them by adding the appropriate, the number of subscript, by basically switching the charges. So how do we know that hydroacids have a nonmetal from the right-hand side? Because hydro means, remember, no oxygen. Okay. So let's take a look at an example. Hydrofluoric acid. Hydrofluoric acid. Okay. So hydro, first of all, this means no oxygen. So what does this mean? It's going to be H plus 1. And then we're going to be looking for an element that has this beginning. Okay, this is an element from the right side that has this beginning. So what element, okay, has the beginning of fluor?
Fluoride.
Fluoride, yep, it is fluoride. And what is the symbol of fluoride?
F.
F. And what is the charge?
-1.
-1. Thank you. So the charges are the same here, which means this is just HF. Okay, and that's it. That's it. There's not much to it. The charges balance themselves out. You don't have to do much. How about acids that don't have the word hydro? What do we do with those? So acids without hydro. To write these, first of all, again, the positive is always H plus 1. The positive is always H plus 1. Then it all depends on the ending of that acid. So if it's an ic acid, originally your polyatomic ended in ATE. So how do we know these were polyatomics? Because they don't have the word hydro, which means they are a polyatomic and they end in ATE. So the polyatomic, we would change the ic back to 8 to find the right polyatomic. If the polyatomic ended in OUS, okay, then the original polyatomic ended in IT. If the acid ends in OUS, then the polyatomic ended in ITE. Okay, so we have to change it back to ITE to figure out the correct polyatomic. And then we just, again, balance the charges. Okay, let's take a look at this one. Carbonic acid. Carbonic acid. Okay, first, we know this is a polyatomic. Why? There is no hydro. You don't see hydro there, which means there is oxygen present, which means this is a polyatomic. Okay, so again, my first one is always going to be H plus 1. How do I know what I change it back to? So if the acid ends in ic, you're changing it back to ATE. If the acid ends in OUS, you're changing it back to ITE. So ic. What are we changing ic to, guys?
ATE.
ATE. We're changing it to ATE. So this is carbonate, which means carbonate is going to be what's going to be next here. So looking at your polyatomic chart that's up here, find carbonate.
CO3.
And what is the charge?
-2.
Thank you. Okay, just switch the charges. The charges do not match, switch the charges. I need 1 carbonate, I need 2 hydrogen. That's it. Okay. What I want you guys to do, oh my goodness, these emails. I want you guys to try this one on your own. Okay, try this one on your own, please. All right, guys. Nitrous acid. Okay. First of all, always look for this. Is there hydro anywhere here?
No.
No. So that means there's oxygen present, and that means that this is a polyatomic. You need to make that connection right away. You need to figure out hydro, no hydro. No hydro means we have a polyatomic. Okay? And then also know that every single acid always begins with hydrogen. So that's like you half of it done already. You know that the first half is hydrogen. Okay. So what is my second half going to look like? Well, remember, we need to change OUS. So IC changes to 8, OUS changes to 8. So what are we changing OUS to? The nitrose?
Ice.
Ite. We're changing to nitrite. Right? Nitrite. So nitrite, if you look in your polyatomic sheet, it's NO2 minus 2. Where are you looking? You are looking here. Okay. As you can see, oh, it's not NO2 minus 2, it's NO2 minus 1. I'm sorry. I'm like, wait, no, it's NO2 minus 1. My bad. It's minus 1, yes. Okay, charges match. You just need one of each.
Wait, I'm confused.
Why?
Because on the top is nitrite and it says NO minus 2. Oh, NO2 minus 1.
Mm-hmm, mm-hmm.
Okay.
Yep. All right. So that's those. So real quick, before I actually give you these, sorry, let me go back to my computer. I forgot to mention one more thing here. So this is back in the Google Classrooms. There's something here at the end that says polyatomics not in list. So you guys have this list, right? You have all your polyatomics here. Let me tell you right now, those are not all your polyatomics. There's these 9 that I don't know why they're not on there. I guess it was like a space kind of purpose, like for space purposes, they don't have them. But you guys do have, I made these for you. They're in alphabetical order and they're also in order by the charge that they are. So this is an extra thing that you do need. So this is 2 options that you can do. Either A, if you're at school, you can obviously print this. It's easy. Just go ahead, print. If you're at home and you have a printer, obviously that also becomes easy to print. If you're at home though and no printer and can't go to school, simple is grab a piece of paper and write it down. It's only 9 of them, so it's not like it's a lot of them. Okay, grab a piece of paper, write them down because you do need it with these. Okay, like I said, this doesn't have all the polyatomics. With this list and this list right here, you have all the polyatomics you need. Okay, so again, just copy it down if you can't print it. Okay, that's going to be the best way. So now that I told you that, all right, what I want you guys to do is I want you guys to do these 4 problems. This one, just an FYI, this one you will find in that new polyatomic sheet that I gave you. Okay, but the rest of them you should be able to find in the regular sheet here. So what I want you to do is take about 10 minutes, see if you can figure these out, okay?
Wait, what did you say about oxygen, how do you know when oxygen is present?
So you know it's a polyatomic when there's no hydro. So hydro means no oxygen. So hydro
Mhm.
means no oxygen. And then no hydro, when you don't have hydro, that means that there is, yes, oxygen. So that's a polyatomic.
All right, thank you.
And also just an FYI, ic is you change it back to 8. OUS, you change it back to ite.
Miss Gonzalez.
What's up?
So for the second one, since it's IC at the end, it will turn into ATE, but I can't find it
Okay.
on.
First of all, Jenny, so this one you see that it has the word hydro.
Oh, yeah. Never mind. I just realized that.
Okay.
Thank you.
right, guys, let's take a look at this. First one, phosphoric acid. Phosphoric acid. So again, it all, like I was telling Jenny, it all depends if you see hydro or not. So, do we see hydro there?
No.
No hydro. Okay, no hydro, which means this is going to be a polyatomic. This is going to be hydrogen plus 1, and this is a polyatomic. Now, what do we change ic to?
ATE.
Yes, ATE. So we change this, and it's going to be, and by the way, we actually take off ORC or ORIC, and the reason why we take out all ORIC is because phosphate and sulfur are very tricky with their naming. So that's why we take it off, and I mentioned that yesterday. Okay, and I'll make sure I mention that tomorrow and today as well. So phosphate, we actually take off the whole ORIC. So this would be phosphate, and you're going to be looking for phosphate in your polyatomic sheet. And what is the symbol of phosphate?
PO4
Okay, and what is the charge?
-3.
Okay, this is PO4 minus 3. Again, remember, just switch the charges. So I need 1 PO4, I need 3 H's. Okay, next one. Hydroiodic acid. So hydro. Hydro means no oxygen. There's hydro here. That means there's no oxygen. So that means it's going to be hydrogen plus 1, and then we have an element. Okay, and the element we're looking for begins with IOD. The element we are looking for begins with IOD. So what element do we have that begins with IOD?
Iodine.
Iodine. And what is the symbol of iodide?
I.
And what's the charge?
+1.
Not +1, -1.
Yeah, -1.
Yeah. Okay. The charges match, meaning it's the same +1, -1, so it's just HI.
I have a question. Where would you find that one?
Iodide.
Yeah.
So you're just looking. Remember, that's IOD doesn't have the full name, but it's on these are on your right hand side. So whenever you have the word hydro, they're going to be on your right hand side, and iodide is right there. It's the only one that begins with IOD. None of the rest begin with IOD. You see, it's number 53.
I see it.
Okay. All right, let's look at the next one, Carbonis. Again, no hydro, right? We don't have hydro, which means this is a polyatomic. Which means, again, it starts with hydrogen, always starts with hydrogen, but we're going to remove this OUS. What are we going to replace OUS with?
Ite.
Ite. Carbonite. So you're looking for carbonite, and again, like I said before, you're going to be looking here. And carbonite is right there, -2 charge. It's CO2 -2. Okay. And again, you're going to switch the charges. You need 1 carbonite, you need 2 hydrogen. So this would be H2CO2. All right. Last one. Do we have the word hydro here?
No.
No hydro, which means that this is again going to be a polyatomic. So it's going to be hydrogen plus 1 plus a polyatomic, but we got to remove the IC. And what are we replacing IC with?
8.
8. We're replacing, and so we're looking for perchlorate. Perchlorate. We're looking for that polyatomic. And that polyatomic, by the way, it's ClO4 minus 1. Again, Cl, not Ci. A lot of people say Ci, it's Cl. ClO4 minus 1. Charges match. Oops. Oh my God. So, I was supposed to do these. Hold on. Sorry. Let me do them in black. Okay. Charges match, which means we just need one of each. Okay. So these are kind of the answers right there, the ones that we just did. Are there any questions on these?
I have a question.
Yeah.
So for the charges, you know how you say you switch the charges? What's it called? The charges have to be on the bottom of the elements?
If it's more than one, yes. Only if it's more than one. So for example, we go back. Let me just go back real quick. So for like the first one and the third one for phosphoric acid, we need the 3 would go at the bottom, or in this case, don't worry about it because you're just gonna write a big 3 anyway.
Okay.
Yeah, and this quiz, you can't write little 3s.
Alright.
Okay. Yeah. Other questions? All right. So guys, that's kind of right now, that's it. So we kind of covered for acids, we kind of covered the beginning, and we also covered the writing of the names and then the writing of the formulas. And from that, we actually got pretty far. Like I said, we're gonna do bases actually on Monday. So please join on Monday, even again, if it's not your color day. Try to join on Monday so you can finish the lecture and you know what you're doing. Bases are a lot easier. Bases, by the way, bases don't have this many rules. Bases are pretty basic, okay? And yeah, so we won't have crazy rules like these, okay? I'm just gonna let you guys go. I'll just a couple 5 minutes earlier because I need there's someone that in this class that was excused today that couldn't make it. So I have to just send this to them. All right. All right, guys, have a great day. I will see you guys on Monday.
Thank you.
Mhm.
Thank you, you too.